All right, for our second gas stoichiometry problem, I made a little bit of a change to this problem from what you have in your notes. So go ahead and make that change as well. I wanted to make this a limiting reactant problem. So I'm going to change this excess water to now I have 8.5 times 10 to the 24th molecules of water. Okay, so when 45 grams of lithium metal react with 8.5 times 10 to the 24th molecules of water, calculate the volume of the gas produced at 4.5 degrees Celsius and 292 kilopascals. So first thing we want to do is write out our equation. So we have lithium reacting with water. And if you look on your reaction sheet, this is a single replacement reaction. You're going to get lithium hydroxide and hydrogen gas. Next up, you want to make sure it is balanced. All right, so step one, we're going to use stoichiometry again, except this time we have a limiting reactant problem. Okay, and this is, we're finding moles of gas. So our moles of gas in this case is going to be our H2, our hydrogen. All right, so we're going to do each of our reactants to moles of hydrogen. So I'm going to start off with my lithium. So I have 45 grams of lithium. So I'm going to convert that to moles first using molar mass of lithium. So grams of lithium on the bottom, moles of lithium on top. So it's going to be 1 mole. And then off the periodic table, that is 6.94 grams. And then I'm going to go from moles of lithium to moles of hydrogen, which is what I'm trying to get to. And again, you're going to use your coefficients, so 2 and 1. Multiply across the top, divide by what's on the bottom. And we should only have 2 significant figures because of that 45. It ends up being 3.2 moles of hydrogen for our lithium. You do the same thing with water. Find out how many moles of hydrogen we can get from our 8.5 times 10 to the 24th molecules of water. So first thing we're going to do is go from molecules of water to moles of water. So this is where we're going to use Avogadro's number. So 1 mole, 6.022 times 10 to the 23rd molecules. And then we can go from moles of water to moles of hydrogen. And that is also going to be a 2 to 1. Okay, multiply across the top, divide by what's on the bottom. Again, we should only have 2 significant figures. And when you do your calculations, you end up with 7.1 moles of hydrogen. So because this is a limiting reactant problem, we're looking at which is our least amount of hydrogen that we get, and that's going to be our limiting. So that is our 3.2 moles of hydrogen. All right, so step 2, we're going to use PV equals nRT to find volume. Okay, so plug our numbers in. So pressure is going to be that 292 kilopascals. Volume is what we're looking for. N, that is our 3.2 moles. R, 0.0821. And temperature, 4.5 degrees Celsius. We're going to go ahead and change that right into Kelvin. So 277.5. And then our other thing we need to do is make sure that we have our pressure in ATM. So we need to change that into ATM. That ends up being 2.88 ATM. All right, plug our numbers in. and solve. And your answer should only have two significant figures since our 3.2 is two significant figures. So calculations, you should get 25 liters.